Jim, you released a video called Climate Tipping Points, and you went over a few things that I thought were very interesting. And then I'll link the video Jim did below in the description box. Please check it out. So Jim, you did a great video, 40 minutes. It was worth it. I made sure to watch all of it because I thought, these are the important issues going forward if you're looking at climate change and the climate crisis. And one of them was, you said, runaway loss of ice sheets. Let's start there. These are the tipping points. We have
Yeah.
passed so many
So
different levels. Yeah, go ahead.
so with the ice sheets, you're talking about Antarctica and Greenland. We're talking about land ice sheets, right? Yeah.
Correct.
Well, Thwaites Glacier, then the scientists are now concerned that it's on the verge of collapse.
Right.
And if that were to collapse and drop into the ocean, sea levels could rise conservatively 3 to 5 feet.
Okay, which is a big deal.
Which is a big deal. That would affect a lot of coastal cities around the planet. But if Thwaites goes in, Pine Island is not too far behind it. They're kind of like tucked up against each other. So it's very possible that Pine Island will soon also tumble in, collapse, and go into the ocean. And that could raise, I don't know what the estimates on that one are, but that could be another significant increase in sea level rise.
So sea level rise is essentially imminent now. We have passed the point of no return. There will be sea level rise. I know you said like there's BS things to put like a wall over surrounding Antarctica, but
are you? I don't know if I mentioned that in that video.
I want to say you did.
But when you make concrete, one of the ingredients in concrete is cement. Making cement is extremely greenhouse gas producing intensive.
Oh my gosh.
To make cement, you put a lot of CO2 into the atmosphere. So we want to build a wall to hold back the ice by building a concrete wall made of cement where we pumped in loads of CO2 into the atmosphere. Excuse me while I shoot myself now.
Seriously, like, oh my God. But yeah, there's no stopping this. I mean, the Arctic is warming, you said 3 times faster was another point, instead of the 2 times. You see it with what's going on with all these ice sheets and the glaciers. They're accelerating is a word we've used before.
I've got a video coming out about Greenland. There's now a thing called slab ice. And this is interesting because in Greenland, you have the summer month, so you are going to get some melting on the top of the surface. Some of the ice and snow melt, and you get these little pools on top of the surface. Some of it just work its way down into the snow and ice. Most of it usually stays there, so then when winter comes, it refreezes in place. Well, now there's this new thing that they're finding called slab ice. And when this water hits this slab ice, it's very solid. It's not very porous. This water hits the slab ice, it runs off. It's not contained anymore. So now it runs off into the ocean.
Oh, no.
So adding to the increasing sea level rise. It's a new thing that they have noticed in the last decade or so.
New phenomenons, right, keep happening.
Yeah.
Jeez.
So as I've got a bunch queued up. It all depends.
Okay, so stay tuned.
I do the upload, and then sometimes it just kind of goes in the middle of the night, and I lose everything. I have to redo it. So that's why it takes me so long to get videos going.
No, your videos have been good. I caught up, so I'm all caught up, and they're good. Because also, this was a different video, but just sneaking it in was the zombie wildfires was pretty interesting. Just it's so hot that fires are continuing to burn.
Yeah, they smolder under even under the snowpack. Yeah, it's just it was interesting. It is. I mean, it's just not as cold as it used to be. So that's what's going on with the we're losing more and more of the sheet ice. Of course, the sea ice itself, that does not affect sea levels. I mean, because you freeze the oceanic water and then it melts, so that does not change the sea level itself. But the the loss of the sea ice has other implications, such as absorbing heat energy instead of reflecting heat energy. So now that's a contributing factor, not the factor, but a contributing one as to why the Arctic is increasing, in, is warming faster than the rest of the planet. But that also affects the productivity. You instead of having the ice edge productivity, which is one group of phytoplanktons, and then when there's no more ice, you have another group of phytoplanktons that do their thing. So we're losing the productivity from that. But for the oceanic phytoplankton, they need the sun to be at a certain high angle to get going. And so they have to wait a little longer in the year. So it's not like, oh, there's no ice edge here, so it will be just the other phytoplanktons kicking in. No, they can't kick in until the sun is at a sufficient angle to activate their chloroplasts.
Does this go into the ocean circulation that you were discussing? Like it's all getting disrupted essentially?
Ocean circulation is getting this, that's the conveyor belt, as it's colloquially called, which is slowing down. We have there is data that showed that had measured the slowdown, the sinking rate. So this isn't like speculation. We're measuring this. We're actually measuring this, and so if think of it, it's a conveyor belt. So as the water sinks in the North Atlantic, it does what? It pulls the Gulf Stream with it.
Right.
Well, if this if this slows down, it's not going to pull the Gulf Stream with it. So now you're not going to really be distributing that heat to the UK and Scandinavia, for example. They start cooling down.
Yes. This is a global, you talked about like the micro changes in past climates, the little ice age and then the the medieval warming period, from the ice age, humans in our current state, like the past 10,000 years, right? We've had that warming and then a little ice age and then now we've spiked up. But, now it's accelerating and you said 9 degrees Celsius by 2100. Okay.
That's what a current paper is extrapolating based on their models.
So I appreciate,
so you're referring the lessons from the Eocene video, right?
That too, yeah. It's all. I mean, they all relate, but yes.
But that's what they based their analysis on. They want, we have a saying: if you want to know what's going to happen in the future, look at the past.
Exactly.
And they looked at the past and they're saying, oh, when temperatures did this, or when CO2 levels did this, temperatures did this. And they're saying, well, it looks like we're heading to those particular CO2 levels, which means we're probably heading to those temperature increase levels as well.
Well, we're talking, okay, so we're around, I know okay, so NOAA says 1 degree Celsius, and that's like the conservative, but it's really like 1.3, 1.4 right now, essentially, since pre-industrial levels. When you talk about, like, we have 80 years left of the century, right, or so, you're talking about like a 1.3 to a 9. I mean, that's amazing.
Yeah,
and
it is. It's mind-blowing.
Yeah, it's mind-blowing because it used to be 3 to 5, right? We're like, oh, the conservatives 3 degrees Celsius, highest maybe 5, and that was like 4 years ago. I saw a graph that showed that, and now, estimates are coming in that it's more like, because of so many other things coming in and changing that trajectory, like the hurricane graph, where's it going? It's going up, but 9 degrees C is on. What does that even? How do you even quantify that? Or
well, I think given current projections and thermal inertia, 3 to 4 degrees C by 2100 is, I would say, almost a given.
Okay, yeah, that's the conservative, right? But
that's that almost a given. Not, we never say 100% sure in science, but I would say a very strong probability that will happen. 9 is probably on the upper end of it, so it might be 5, it might be 6, might be 7, but that's still incredible, in this short time frame. Look what's going on in Siberia. The temperature anomaly, it's like 8, 9, 10 C warmer than it usually is. So we're already seeing something like this in Siberia. Now, the other
Exactly.
important point is, yeah, as I talked about, we had, maybe this region, even it's a big region, this region cooled down, this region warmed up. Maybe it was even hemispheric. But now we're seeing a whole damn planet. Everything is synchronous in one direction, that of warming. When you've got 92 to 97% of the surface area showing temperatures warmer than average, that is a synchronous unidirectional shift.
Yeah, it's not regional like the past where Europe was in like a mini ice age and, elsewhere it was fine. So like
elsewhere is balmy.
We're talking about a global shift and the consequences of that. I mean, you've gone over on your own channel and vice versa. It's just essentially, so the consequences now seem extreme, but you're talking about even further extremes, even like off the charts extremes. I mean, California, for one, we have all these fires, and that's because we talked about the dry winter. I knew it. We're gonna have an issue with this. It's not like, it's not like a profit thing, like, oh, we have the magic ball. It's data in one direction. I'm like, okay, well, based on what's happening now, it's probably gonna get worse, and we see that. But the fires and the dry winter and the shifts of rainfall is changing, and humans have to essentially adapt and continue going like normal. It's not going to work, but what does that look like? 9 degrees C, I mean, that's extinction, right? I mean, how else can you it's just amazing.
It will not bode well for humans, for human civilization. The problem is,
it's going to be hot.
Because again, I always go back to the rate of change. The rate of change is so fast that humans and others, do not have enough time to adapt. No. And this can lead to extinctions. So that you got that. I have another video coming out soon where I talk about how humans arose in a globally cool planet.
Okay.
Where the CO2 levels is like in the 200s.
There we go, yeah.
When we first started, we're talking going back to the Bronze, Iron, Stone Age, that kind of stuff, going way back then. So humans actually came to be adapted for a cooler, lower CO2 level world.
Yeah, from the Ice Age, we've thrived, but we're now going off the charts.
I mean, look what just happened in Death Valley, right? 130 degrees in Death Valley.
Yeah, it's amazing. Sorry, this is the reality. It's warm. It's like 90 degrees. I got glistening. All right, continue on. Yeah, Death Valley. It just broke a record, right? So extremes are getting more extreme.
130. In a very aptly named place, Furnace Creek.
I love it. We talked about this.
I mean, you couldn't make this up.
There's no.
Hey, Furnace Creek today was the highest official recorded temperature ever, 130 F.
Oh my God, Death Valley. Oh my God, Jim. Yeah, so 130 and it's like 54.4 degrees Celsius, those degrees Celsius. But yeah, 130 is just what the. And if the world gets warmer, that's gonna be like nothing. But even the warmest places are getting warmer. So these extremes are happening.
And there's speculation that the Middle East may get so warm that it'll become uninhabitable.
Mind blown, right?
So now you're going to have all those climate refugees.
And that war and all this fight for resources.
So we got more and more people. Now you make less and less land livable. So now you're going to start packing in more and more people. You're going to increase the density of the population. That usually doesn't bode well. Little experiment. I don't know if you ever saw this in like high school or something like that. What happens? You put too many rats and mice in a cage.
Oh no! What happens?
They eat each other.
Yeah, cannibals. Oh God.
They eat each other. I don't know how many times I go in there. It's like, oh, it's just a tail and the ass end of this one. The rest was eaten.
Because they're fighting for space. They got to eliminate.
They're fighting for space. Exactly.
Goodness gracious! I mean.
And
it's a good example.
That's where I see us heading. That's where I see us heading.
Absolutely. If there's less and less land, less and less resources, I mean, you can't rely on the grocery store. I mean, the average person, are they
Yeah.
prepared? I mean, 10 billion people, maybe less, you know, who knows when all this erupts. I mean, it's erupting now, but it's slow motion still a little bit, you know.
That's why I still maintain, that there's going to be a huge crash. It's going to be a huge crash. And I think COVID and any other pandemics that might appear is going to push those numbers even lower, push the human numbers lower. Because keep in mind, the carrying capacity of the planet Earth for number of people, depending on which study you look at, is between 100 million and 700 million. The point is, it's under 1 billion.
So like,
and we're at 8 billion now.
Without industry, right? That's the natural like number that we could sustain.
Right, that you can harvest resources, but then allow the resources to be replenished. So that you can cut down some trees, plant trees, they grow. So you're not basically outstripping the resources.
How fascinating, Jim. I mean, that's we are way beyond that. No wonder shit has hit the fan. It's like,
we are.
Like the rats. I mean, there's too many rats. They're going to essentially eat each other. We're going to have conflict as humans, and other species are going to be affected too, just in general, because, their land is decreasing as well. So it's going to be, I hate to say chaotic. I mean, I think even more than that. I don't, unpredictable chaos theories, you like to say.
Yeah.
So going on, you use the term in your video, hothouse Earth is a term, a direction we're going, right? It's like this extremely warm world. You can't really live at the equator. You have to live in like a certain area. The Arctic has like palm trees. Like, what are we, that was the land of like the time of like reptiles, right? I mean, that's when things.
Now keep in mind, this is well before humans ever showed up on the scene. Planet Earth was an extremely warm place. Right. Because you had no continents at the South Pole, so we had open water there, so they could absorb sunlight energy. Ocean circulation was more zonal, so it really helped keep the heat in the heat band. So, and the continents were in different configurations. So the planet was overall warmer because more sunlight energy was being absorbed. There was less ice. It wasn't until the continents started moving around, then you have North America and South America take up their position. Then you had the Isthmus of Panama, form, come out of the water, and that then creates this Gulf Stream, and then it starts this whole, current circulation patterns we've got, and then Antarctica goes to the bottom. And once Antarctica went down there is when the planet really started to cool down. Because now you can get the precipitation coming down as snow, it starts compacting, accumulating, etc., etc. So.
And all that's unraveling now, but yeah, it took so many years, millions.
So when people say, well, Earth was a lot warmer in the past, true. Humans went around.
Exactly.
And also, the rate of change was much, much slower than it is today.
And you said, it's way back, I just thought of this. It's hard to understand like past climates, but the Jurassic, that area, there was more oxygen in the air. That's why there was bigger creatures.
Yeah.
And now we're going towards less oxygen.
Now we're about 20, 21%. O2. It used to be as high as 27, 28%. More oxygen, you can run bigger metabolisms or faster metabolism. So a larger organism can get the requisite oxygen to feed all its cells. So that's why you had the big sauropods.
Right, they're huge.
And you had dragonflies with 18-inch wingspans. This is my pet dragonfly here.
Let me go ride my Tyrannosaurus Rex. Oh God.
It's like imagine all the mosquitoes they could have eaten. But anyway.
Oh my God.
But then the mosquitoes would probably be this big too, and they can like really drill a hole in you.
Oh shit.
joking. Of course, we have the fossil evidence that indicates they weren't that large, but
Oh my God, but that's hilarious. But bugs were bigger. I mean, that's
yeah,
right.
we're
Look,
talking like Carboniferous Devonian era.
oh my
It's like
God.
actually
Wait,
more
so
Carboniferous.
the last point I had for you with your climate tipping points was one last thing was just the amount of CO2 in the atmosphere in 2019 alone. I thought was interesting how you said that. Like just
Hey,
well, how much one
remind me.
year? So what in
I'll
one
put the
year,
clock
how
up.
much CO2 in the climate tipping points video? Like the last point was the amount of CO2 in the atmosphere in 2019 alone. So every year, how much it gets emitted just in 1 year? How much gets emitted in just 1 year is amazing.
Yeah,
And
yeah,
then where
it's
we're going, 1,000 ppm, or ppm, excuse me.
yeah, it's incredible. I mean, I think they've now measured 415, 416 officially.
Right.
At least on a couple of occasions. Whether it's the new average, I don't think so, not yet, globally, but it still just keeps going up. So if you think that, however millennia ago, humans lived in a world of about 240, 250 ppms of CO2, and now it's 415, that's almost a 200 increase. But the increase from 350 to 415 has occurred in such a short span of time, like 50, 60 years or so.
So exponentially, yeah.
So it's just, yeah, we need to. And so now what's the Trump administration do? Let's approve drilling in Anwar.
Yeah, I think I heard that. Just we're still exploiting all these places in the Arctic. I mean, there is no end in sight. We have our issues, and we can mitigate, not stop them anymore. That's the whole point. We have passed the point of no return, essentially, with this. There's enough thermal inertia, and the Trump administration keeps pushing and pushing to exploit, even though we know using fossil fuels, etc., are going to continue to further warm the planet. So we're at
I mean,
a
and the thing is,
precipice.
they're talking about targeting the coastal plain. That's where the caribou go to have their calves. They need to get access to the oceans to get away from the mosquitoes, which absolutely torment them. It's where you got polar bears. That's an endangered species. It's still on the endangered list. So that is technically an illegal action. Not that I'd ever stop Trump, but it's also an important, for the Gwich'in. They need that area for subsistence living. And to develop the oil, you got to put in this massive infrastructure. You got to build roads. You got to build pads. You got to bring in heavy machinery. And you can't really do that during the summer months
No.
because the ground is so boggy. You can only do the stuff during the winter. In fact, that even when you go to Prudhoe, they have to get off the tundra by March.
Yeah, because
That's actually by law. So they're doing all their stuff in the winter, in the dark of winter. So you got to put in all this infrastructure, and the oil companies have basically said, "Well, we don't think the investments will provide us with a good economic return." Translation: we ain't gonna make money out of this.
mm-hmm.
So I don't think I don't see the oil companies actually rushing out there. And here's another thing: the oil that's in the ground in the North Slope tends to have a very high sulfur content, which is like the least desirable type of crude oil you want. Anything with a high sulfur content, because it takes you need to pull out the sulfur, you need the scrubbers and stuff like that. It's more expensive to refine, and it's a longer process to refine. So when in the past, well, we need, America needs this oil up there, blah blah blah. You know what they do? You know what they do with the oil from Prudhoe?
What?
They ship it to China and Japan. They're going to do this if Anwar goes on. They're going to do the same thing. Ship it to China and Japan.
To
Ship
make
it
the
to the Asian.
almighty buck, yeah.
Ship it to the Asian markets. That's what they're going to do, because the refineries here don't want to be bothered refining high sulfur oil. They don't.
It's just very frustrating. I mean, we continue, not we, but those that have this power continue to exploit, knowing, this greed issue is
Yep, money.
money for what,
Short term. Yeah. Well, let's see. Can you drink money? Can you eat money?
No, I mean, you really can't. I'm sorry. You could try.
What was the end of that Bond film, Quantum of Solace, where he gives him a couple of cans of oil?
Yeah, it's
He's
like,
not.
that's weird. I
I'll
was
give you about
thinking about
5 miles before you.
remember, like, the chick got doused in oil and that's how she died? It's just like, I was thinking about that. That's interesting you brought that up.